question 13. So part 1, the vertical height of V above the ground, so basically the length VO. So I'm going to consider the triangle VOC, which I've put over here, VOC. Well, clearly the length VC is 2.4 from the question. Now I think a really significant point of this question is appreciating how a hexagon works. We're told that the length AB and BC and CD and so on is 0.5, but you've got to appreciate that's also the length 0 to C or 0 to B, because 0CB is an equilateral triangle, as is AOB, etc. All those lengths are 0.5. So once you've cracked that, I think this is fairly straightforward. So back to our triangle VOC, we know OC is 0.5 and VC is 2.4. So our length VO, just using a taking away Pythagoras, is 2.35 to 3 sig figs. Now part 2, the angle between each cane and the ground, so this angle X VCO, so using the same triangle I can say cosine X adjacent over hypotenuse is 0.5 over 2.4, so X is inverse cos 0.5 over 2.4, which is 78.0 degrees to 3 sig figs. Now part 3 is really picking up the angle they need, the angle between the plane VAB and the ground. Now if you consider the midpoint between A and B, which I'm going to call G, we're looking for the angle VGO. VGO. So first things first, let's work out from triangle VAB, let's go and work out what the length VG is. So I'm starting to try and work out what V to G is. So what do I know? I know V to A and V to B are 2.4. Because A to B is 0.5, A to G is going to be half of this, 0.25, because remember G is my midpoint between A and B. So using a taking away Pythagoras, I can say VG squared equals 2.4 squared, take away 0.25 squared, which is 5.6975. So going to my triangle VGO, my length VG is root 5.6975. My VO, back up here, is root 5.51. So my angle Y, using sin, opposite over hypotenuse, sin Y equals root 5.51 divided by root 5.6975. So so obviously Y is inverse sin this division, give me Y being 79.5 degrees to 3 sig figs. Now for part 4, the gardener stretches a horizontal wire around the structure to strengthen it. He fixes the wire to each cane at a point 1 meter vertically above the ground. So this is going to be a similar hexagon question. It's similar shapes. So we know that the perimeter of the hexagon on the ground is obviously 0.5 at 0.5 at 0.5 all the way around, 6 lots of 0.5, which is 3. So what we've got to consider, what is the relationship between the base hexagon and the hexagon which is going to be 1 meter up. So let's go back and have a look at our triangle VOC, and we're considering one of the lengths of the hexagon. Now obviously we know the if we do it by way of height, okay, we look at the ratio of height, we know the length V to O was 2.35 from part 1. The height we're interested in from V is 1.35, so because we're told that it's 1 meter vertically above the ground. So by looking at similar triangles, can you see that this is basically going to be the length of each side of the hexagon. So on the base we've decided that each of those all the way around is going to be 3. In other words, each length is 0.5. Now the proportion, the length of each side of the hexagon 1 meter up is going to be in the proportion 1.35 to 2.35. So just take it, so doing it completely by the perimeter of the hexagon, I need to multiply my total perimeter of the hexagon at the base, my 3, by the proportion 1.35 to 2.35, because that length times 6 will be my hexagon 1 meter up, and that gives me 1.72 meters to 3 sig figs.